Perspective Class 1 Video 2. Let's look at the motivating question for this module. The question is how to best represent a three-dimensional object in 2 dimensions. And the word best is in quotation marks because it's not really like a mathematical word really in this sense, because it's too ambiguous of a word. Exactly what I mean by best is a non-trivial concept, and we're going to discuss it a bit later on. But for now, let's look at a partial or a naive answer to this question. So how to best represent a 3D object in 2 dimensions? Well, the answer is you project it. You project the 3-dimensional object onto a 2-dimensional plane. Okay, but why is this only a partial or a naive answer? Well, life is complicated, and it turns out that there is more than one way to project a 3D object onto a 2-dimensional plane. There's more than one type of projection which you could use, and depending on your needs, depending on why you're trying to project a 3-dimensional object onto a 2-dimensional plane, will influence what type of projection you use. So for example, if you're trying to make hyper realistic computer graphics, then you might want to choose a projection that prioritizes real looking results. So you choose a projection that prioritizes sort of real life looking results. Okay, so if you were making a hyper-realistic computer game or doing CGI for a movie or something, you'd want to use some sort of projection that had real looking results. But you don't always want this. Like if you were designing a 3D product, then maybe you would choose a projection that prioritized conveying geometric data. So stuff like length and parallelness. Right? If you were drawing a blueprint for a 3D product, then maybe the most important thing is conveying its dimensions, its length, width, height, and also whether certain lines are parallel or not. And maybe you would choose to use a different type of projection in this case than you would in the first case. This issue of there being more than one way of projecting a 3-dimensional object into 2 dimensions, it's directly analogous to the issue of like trying to draw a world map. You know, if you've it's well known that there's no perfect way of drawing a world map. It's impossible to represent a spherical object on a flat piece of paper truthfully, 100% truthfully. But there are different ways of doing it, and the different ways have their benefits and they have their drawbacks. For example, a very common way of representing the world on a map is the Mercator projection, which is this one on the left. Okay, it's very common, and it's used a lot in maritime navigation. Okay, but it has drawbacks. I mean, the biggest drawback is the massive inflation of sizes of countries near the polar regions. So like Antarctica here is enormous on this map, but it's way bigger relatively on this map than it should be. Okay. Whereas another type of world map projection is called the Lambert projection, and this projection, maybe it's worse at some things, but now it keeps the relative size of the countries equal. Okay, so just depending on what your need is, you choose the correct projection, and that's what's going to happen in this module with perspective. Depending on what the need is for having a perspective drawing of a three-dimensional object in 2 dimensions, you choose one type of projection over another type of projection. So there are 2 main types of projection. From 3D to 2D. There are more than 2, but there's only 2 main types which we're going to be focused on in this course, and they're called parallel projection and central projection. Okay, and throughout this course we're going to study these 2 types of projection. These are the most important types of projection, and we're going to study them. But before we do so, we first need to recap some basic coordinate and vector geometry. So that will be in the subsequent videos. But that's the end of this video.